Oh, now I know why sometimes that doesn't record. What kind of calculator do you have, Sam?
I don't have mine with me right now, so I'm just going to use the Google one.
What kind is it?
I don't have the one I usually have right now,
Uh-huh.
so I'm
What
just
do you
using the one
normally?
that.
What
Oh,
are
I
you
have it.
using for
I
your
usually have a TI Inspire.
The Inspire?
Yeah, that's what I usually have.
Okay. Um, do you know how to use it for statistics?
Mm-hmm.
Okay, good. Let's just look at this first question. What are they asking for?
How many pairs on average?
They're really asking for standard deviation. Okay. They want to estimate the variability. Well, the variability in the number of pairs is a measurement of the spread of the numbers. So if you fed these 16 numbers or however many there are there, I think there were 20 there before.
Yeah, there's 20.
There's 20. If you fed them into your calculator, and then you do a single variable statistic, they will give you the mean and the standard deviation.
Mm-hmm.
And that standard deviation is basically what they're asking about here. Let's see, I think I got to go to the next screen. I do. Here, let me just go this way. Wants to estimate the variability in the number of shoes by estimating the population variance, sigma squared. Well, variance is standard deviation squared. Okay.
Mm-hmm.
But a true measure of variability is really the standard deviation. The only reason they have a term for variance is because some of the deviations are plus, some of them are minus. And what we're really interested in is the absolute difference between the median, or the mean rather, and each entry. And so your calculator is the way to do it. I do have a formula. I don't know if they expect you to know this or not, but that is equal to, I'll start writing it and you can tell me. So much of what you do is going to be done on that calculator that I don't know that they even want you to memorize these, but they might. I won't write out the whole thing, but in other words, once you have the mean, if you had to do it manually to calculate the variance, you would do it like this. It's all divided by n minus 1. And that's a sequence that goes out to the 20th point minus. In other words, what you're doing is you're figuring out the average of these 20 values. You're coming up with a mean, and that's what x bar is. And then you're taking each number, the difference between the number and the mean, you're squaring it, and you're dividing the whole thing by n minus 1, which in this case is 19.
Are you scoring each of the x minus?
Yes. Sorry, I didn't write it correctly. Yes, that's the way it is. It's complicated as to why it's n minus 1 and not n. And I don't think we need to go through that. But that's the variance. And so the standard deviation is the square root of all of that. And that's what your calculator does. If it has all of your x sub 1, x sub 2, up to x sub 20, then it just does the calculation for you and gives you a standard deviation. Okay? That would be standard deviation. And there's lots of ways to talk about standard deviation. There's another Greek letter that's used, I think, mu. Have you come across mu before?
Yeah.
Okay.
We use that one occasionally.
Okay. Yeah, I think they're pretty much interchangeable. Okay, so that's all we would do here. Now, I don't think we want to go through this math, but you could manually. It wouldn't be that hard to do, but much better to have your calculator do it.
Mm-hmm.
Okay. All right. They seem to be all over the place with these questions. In other words, you have to know about z-score. You just do. So I kind of had to go back and refresh all my z stuff.
Mm-hmm.
Okay, so in fact, all of these seem to be more conceptual in nature than they are figuring out precise numbers, right?
Mm-hmm.
And that's probably because you get your precise numbers from your calculator. You're not really doing any work on that. So here there are 750 seniors. She interviews a standard random sample of 50, and she finds 36 plan to go to the prom. Where's the question? Estimate what proportion? Okay, so the question is, what is her estimate? What do you think it is?
Well, doesn't she? Let's see. I'm not sure. She needs to do.
Well, if she interviews 50 and she finds 36 plan to go, what rate is that?
Just 36 divided by 50.
72%. Now, that is the best rate she can get by interviewing only 50 people. If she interviewed all 750 seniors, she would find how many were going, and that would be the true mean. But she doesn't have the resources to interview all 750, so she takes a random sample. And the only number you can get from this is 72%. I thought maybe it was a little more sophisticated than that, but I don't think it is. I think it's just that's the answer. In other words, the 750 doesn't. The only thing that 750 does say, there is another concept here that's worth talking about.
Mm-hmm.
And that's the critical, what is it? The critical value theorem?
Yeah, critical value.
Yeah, and that's a little hard to understand, but I think I can explain it simply with this question here. If she were to take, in other words, she gets a value of 72%, right? Oops, hold on. Let me just draw a little bit on here. And now let's see, she does another sampling. This totally new. Starts with all 750 and pulls out 50 new ones. And she samples that. She's not likely to get exactly 0.72, is she?
Probably not.
No. She might get 0.75. She might find that 3/4 of them are going to go. And she does another one. And this time she finds out that 70% are going to go. And she does another one. And this time she finds out that 78% are going to go. What the critical value theorem says is that the true rate, if you were able to interview all 750, the true rate might be 0.73. Something like that. Well, what this says is that as we do more and more small samples of 50 each, you could take these numbers, plot them, and they will also be a normal distribution. And the average of those numbers is going to get closer and closer and closer to the true mean.
Mm-hmm.
And that's what it really says. Because most of the time, we don't have the ability to sample the entire population. If you're talking about the United States, that's 330 million people. So our best alternative is to take samples of that population. And the more of them that we take, first of all, the larger the sample, obviously the more reliable this number is.
Mm-hmm.
If she done 100 instead of 50, her answer would have been more likely to be close to the true mean.
Yeah.
Okay. Let's erase that. And
Did you look at the confidence interval form or confidence interval set at all?
I did look at that. Want to go straight there?
Could you explain a bit of that to me? Because I don't.
Yeah, I think I can explain it. And that's where I had to go back and make sure I understood the Z table.
Okay.
All right. If another thing worth knowing on these curves
Mm-hmm.
is 1 sigma. In other words, this is the mean. If they're symmetrical,
Yeah.
1 sigma occurs at the inflection point. Notice when the curve starts going concave that way to concave the other way. One way is concave down, the other way is concave up. These are big principles in calculus. But that inflection point right there represents where 1 sigma is. I'm not sure it's exact, but it's approximate. Might even be exact, I'm not sure. All right, let's get back to what we were talking about, confidence intervals. If we were taking 50 samples and we were to take multiple ones of them, and then plot all of our X values, in other words, each sample is going to give you a mean, right?
Mm-hmm.
That's for the first sample. The next 50 is going to give you a mean for that sample of 50. And so what we're plotting in this chart here is all of the individual sample means. And they will also be a normal distribution. In fact, it's called a standardized, well, no, not yet. It's okay. So if we go out to here, I think I can do this without even bringing in the Z concept. We know that 66% of our X bars are going to fall between X minus 1 sigma and X plus 1 sigma in this 2 sigma range. So if you did a particular sample level, you would know that if I did 100 of these, 50 at a time, I would have a 66% confidence interval level that the true mean is going to fall. In other words, 66% of my results are going to give me the true mean.
Mm-hmm. So it's just...
Now, I put that wrong. I am going to have a 66% level of confidence that my mean on any 50 sample is going to be within 1 sigma of the true mean. That's basically what it means. In other words, it's very similar to the concept of, if I have a normal distribution of the heights of women in the United States, you can say that 90% of them are less than 6'3" because of that normal distribution. Well, that's very similar to saying that if you choose a woman at random, that you have a 93% chance that that woman is going to fall in that area. In fact, it probably makes more sense if I do it like that instead of doing this. This has to do with the critical value theorem, but it's really the classic case is women's heights. Okay, I'm going to make up a mean of 60 inches, 5 foot.
Okay.
And we'll say that 10 inches. So this is 70 inches. And this over here is 50 inches. Okay, 60 inches is 5 foot tall. This would be 5'10". This would be 4'2". Okay. So you'd be assuming they gave me the mean, the national mean, which we have figured out through statistics is 60 inches, and sigma is 10 inches. Okay? So if you were to pick a woman out from random, you would have, because the area under that curve is 66%, you would have a 66% confidence level that she was 60 inches plus or minus 10.
Okay.
In other words, that she would be between 50 inches and 70 inches. Somebody's setting you up on a blind date, and you want to know what your height of your female partner is going to be. You would be 66% confident that it's between these two values.
Okay.
And now over here, there's another, let's see, there's 34% left over. You cut that in half. So this whole area is 17%. So you now would have a 66 plus 17. You'd have an 83% confidence interval or level that she would be less than 5'10".
Mm-hmm.
If you were Will Chamberlain and you were looking for a particularly tall girl, then you would only have a 17% level of confidence that she would be over 5'10". Now, let's look at your problem and see if we can apply it to that. Hold on. I think that's the third page, yeah. Okay, again, they don't ask you to calculate anything here. They merely ask you to interpret. Do you favor an amendment to the Constitution that would permit prayer? That's a yes or no question. And based on this poll, the 95% confidence interval for the population is between 0.63 and 0.69. So interpret that confidence interval. What does that mean?
Wouldn't it be like, I don't know, we're this percent confident that it's between the lower set of data and the higher set of data?
Obviously, if you were to go out and only talk to one person, that person's either going to be for or against, right?
Mm-hmm.
If you talk to 10 people, you might get 5 that were for, 5 against. But if you talk to 100 people, how many people are going to be for it and how many people are going to be against it?
What would you say for that?
If you talk to, well, I'll say 1,000. Let's say you go out and you ask 1,000 people. What do you think the mean would be?
I'm not sure, but it's going to be closer to the true value.
In other words, it's going to be 0.66. What we're looking at here is, the best way to do it is to draw it, I think. So that value right there, if you interviewed enough people, you would find that 66% of them believe that they would favor this amendment. Now, it says there's a 95% confidence interval for the entire population. Well, 95% corresponds to 2 sigma, right? Mm-hmm. So if I went out 2 sigma, they don't tell us what sigma is here, so we kind of have to work backwards. But let's say 95%, let's say sigma is 0.01. I'm going to make up a sigma just so I can explain this problem a little better. That means if I were to do 1 sigma that direction and 1 sigma that direction, we know what this area is, 66%. Mm-hmm. So if this range here were 65 to 67 instead of 63 to 69, that would give us a confidence level of only 66%. Well, they want 95%. Well, we know that if you go out 2 sigma, you'll get 95%. With a different color, let me draw out 2 sigma. So since sigma is 0.01, this is 0.64, this is 0.68, and now we know that 95% of the area under that total curve lies between 0.64 and 0.68. So if we knew sigma, we could do all of those steps. Well, we don't know sigma, but we could actually figure it out going in reverse, although they don't ask us to do that. So we don't need to go through the math of going through reverse. But you can see I'm relatively close. Mm-hmm. Sigma must be a little bit less than this. No, excuse me, a little bit more. In other words, I want 2 sigma to be at 0.63, and I want 2 sigma to be at 0.69. So sigma must be closer to about 0.013 or something. And then, so interpret the confidence interval. And I have to, obviously it doesn't mean if you go up to one individual, they're going to give you a 66%. They can't. They're either going to give you a yes or a no. But if you went up and talked to 100 people, you would be 95% sure that the mean of those 100 people is going to fall between 0.63 and 0.69.
Mm-hmm.
Okay? So that's the interpretation of the confidence interval. What is the point estimate that was used to create the interval? And what is the margin of error? Well, the point estimate, in my opinion, has to be the in-between point, 0.66, plus or minus 0.03. So that's the point estimate, and that's the margin of error. I believe you're going to have to take everything I say with a little bit of grain of salt. As I said, I do not consider myself an expert on this, but I think I am correct on this. You may know more than I do in some parts of this thing. Here's the thing. I read this book 3 times, 3 years ago.
Yeah.
All 3 times. What I did not do was the exercises at the end of each chapter. What I did was passive learning, and it's not as good. You don't really learn something until you do active learning, which is doing the problems.
Mm-hmm.
And so I feel like I have a good conceptual understanding of statistics and probability, but doing the problems is a whole different story. First of all, you got to remember the formulas, and there's a lot of different formulas in statistics. Although you may not have to memorize the formulas if you're doing most everything in your calculator. Now, I'm a little surprised they didn't ask us to calculate sigma, because we can. Because we know 95% is perfect. I don't even have to go through the z conversion. If it was 97%, I'd have to go through the z conversion to solve it. Because I don't know 97%. I know 66%, I know 95%, and 3 sigma out is 99.4%, I believe.
Mm-hmm.
In other words, 99.4% of all of the data lies within 3 sigma of the mean, the true mean. And let's see, what's that last question? I don't think I could see it all. No, I could, sorry. Based on a poll, a reporter claims that more than 2/3 of U.S. adults favor such an amendment. Use the confidence interval to evaluate this claim.
Well, 2/3 is the 0.66.
No, it's 2/3 is 0.667.
Yeah.
Okay, or 0.666666.
Mm-hmm.
So he's claiming that more than 2/3 favor this amendment. And what we have is a 95% confidence interval that true number is between 0.63 and 0.69. So the question is a little bit ambiguous. Clearly, according to this, the true mean is 0.66, which is not greater than 2/3. So I would have to say that he is incorrect to evaluate that claim.
Mm-hmm.
It's close. I don't know whether they mean, precisely 0.667 or not 667, but 0.6666666. Pi, come here. Pi. Sorry, I'm trying to get my dog to stop barking. Okay. But in general, his claim is correct. It is near 2/3. It's not necessarily more than 2/3 though. Could be. If you interviewed 100 people, you might find that 0.68% of them favored such an amendment.
Mm-hmm.
But you'd also as likely find that 0.64% of them favored an amendment.
So basically, he needs to interview more people for his claim.
Well, I don't know. The way they've worded this, I don't really know exactly what they mean, because it seems strange to me that they would distinguish between 2/3 and 0.66.
Mm-hmm.
0.66 is the mean that we came up with. Is that 2/3? I mean, it's close, but he's saying more than 2/3 of U.S. adults. I don't know. I don't know what to add to that. I'm not totally sure.
It's kind of a gray area.
And the next one, I didn't get the
problem. I didn't have to do 10, so.
Okay, cool. Okay, I don't know if I've been helpful at all to you, Sam.
Yeah, I understand the confidence interval now.
And I don't mind. It's like I've read 3 hours of the statistics book over the last 3 days for this half-hour session. I have no problem with that at all, mainly because that's the only way I'm going to become a competent tutor, is to actually have students give me problems. As opposed to, I guess I could go through the book and start doing all those exercises, but I don't have, 6 months to do that.
Makes sense.
But yeah, I love statistics. I think it is a great discrete mathematics topic. So I'll let you decide whether, if you feel like I can help you, I need you to do it on the basis that we did this. In other words, I need you to send me the questions at least a day in advance. And that way, the ideal way for me to tutor you, and this is what I thought was going to happen when I first said I was a statistics tutor, was you'd hire me at the beginning of the semester. I would be able to stay a chapter or two ahead of you, and I imagined it going like that. But what's happened is you've got me, you're 5 months into the subject or 4 months in, and now it's the whole book I have to know, or at least up to where you're at, page 478 or wherever that is. And that's a lot harder for me to do. I didn't even know precisely where. I mean, when I saw the question on confidence interval, well, then I looked in my book, where do they start talking about confidence interval? It isn't until page 628. So I'm a little puzzled with these page 478s. And I got the copy that you sent me at 478, and I couldn't find that page in my book. So they've changed the editions a little bit between your book and my book. That's going to make it a little bit harder, especially if they've really changed the table of contents significantly. And it looks like they may have. So when you send me these questions, if I could also figure out what chapter I need to go to refresh, that would be helpful. And you can give me the page number if you want, or the subject matter. In other words, we're just getting into probability. Well, I know what chapter that is in my book. That's chapter 6 or 7. Okay?
All right.
All right. Sam, I'll let you go. Have a good week. Good luck on your test on Tuesday. Bye-bye.